Welcome to Study Loop.
So when we look at an ionic compound, the relative sizes of the cations and the anions are directly related to the coordination number. In other words, as the radius of the cation is approximately equal to the radius of the anion, you're going to get tighter packing. And as you can imagine, the main reason for that is because if the ions have more similar sizes, they're able to fit around each other easier and there's less sort of disproportion within that structure. So if we consider first cesium chloride that I have drawn here, or that I've taken here from the book, you can see that the relative radii of the cesium cation and the chloride anion are very similar. The balls in the structure are basically the same size. So they're going to fit nicely together and make this nice lattice that has a coordination number of 8. So you can see via the lines that are drawn between the cesium and the chloride anions that there's a coordination number of 8. If we contrast that with this zinc blend over here, zinc and sulfide, the size difference between the zinc cations and the sulfide anions, shown in yellow, is very severe. And because of that, it's not able to take on the same closely packed structure as cesium chloride. And we can see that the structure becomes a little bit more fanned out, and the coordination number between the zinc and the sulfides is reduced to 4. Again, this is mainly because the size difference between the zinc and the sulfide ions prevents them from forming such a nice packed structure. So to summarize, as long as the radius of each of the individual species held together in your ionic solid are about equal, you're going to be able to get tighter packing, which is going to increase the coordination number.